Good morning. Today I'd like to talk a little bit about how to use your calculator to do various sorts of calculations. I'm going to be talking using a TI 8384 series calculator. If you have something else, these comments are useful only in a most general way. Besides doing arithmetic, the frequently used buttons on your calculator include Y equals, window, zoom, trace, and graph on the top row. The second button, which plays the role of a shift key. The mode button. The X button, although other things are listed other than just X. And the math button will occasionally be useful to us. I mean this literally. Here is the Y equals button, the Windows button, zoom, trace, and graph. There's second, mode. We won't have much use at this current time for the alpha button, the X button. And besides our arithmetic, these will be the ones that we use most frequently. Initially, we need to make sure that everything is set up all right. So I'll turn my calculator on, and I'm going to press the mode button, which is right next to the Y equals button at the top of the screen. There's a variety of things that you can set right now. The one that's most important to us is that one. If function is not highlighted, then it needs to be. If, for example, that were highlighted instead of function, then things are not going to go the way I want them to. The way that we change these things is we cursor down to the thing that we're interested in, which in this case is the function, parametric, polar, and sequential line. We put the cursor, the blinking thing, on the thing that we want to select, and then we press enter. And we're now in function mode. Another thing that we need to make sure of is, for example, if I had a used calculator, I had bought it secondhand from someone, when I go into the Y equals menu by pressing Y equals, I'll see a wide variety of things. There may be some formulas in these Y1, Y2, and Y3, and so on. If so, we'll get rid of those in a moment. But the thing I'm worried about is very often, if somebody has taken a statistics class, plot 1, plot 2, or other plots may be highlighted. What that tells the calculator is to plot whatever statistical data is stored in plot 1 or 2 or 3. If we're not doing any statistics and we try to draw a graph, we get an error message. It says that I can quit just by typing enter, so I'll do that. The problem is that we're not doing statistics. This is easy to fix up though. Go into the Y equals menu, and if you see any of these plot things that are highlighted, cursor up, cursor sideways, and press enter. That'll get rid of that one. Go sideways, press enter again, and now they're all out of the way. So if you're getting that error message and one of those plots is highlighted, that's why it's doing that. If something else is the matter and it still won't work the way you want it to work, you may have to do a memory reset, which you do by saying second, and then down at the bottom, Up above the plus, you'll see the word MEM in blue, so type that. This puts us into the memory menu. Depending on which version of the calculator you have, it may look different from this, but one of your choices is reset. Now, if you have any games or data or anything, if you reset, you'll lose them. I don't have any such thing, so I'll press enter on the reset. Then it asks me if I'm really sure. I'm going to reset all memory. It's asking me if I'm really sure. Any data or programs that I had stored in memory are going to be completely gone now. So it resets back to its initial screen, the one that you get when you first turn the calculator on when it's new. I'll get rid of this screen by pressing clear. I want to draw a graph. I'm going to press my y equals menu, which is there. This puts me in the y equals menu. None of those plots are turned on because firstly, we cleared them out by hand, and secondly, we did a reset anyway. I want to draw the graph of y equals 2x plus 1. So I'll say 2. The x button is right below the mode button. You'll notice that it has some other letters and stuff on it. We'll see some of that later as we go on. So y1 is 2x plus 1. Now, to get out of this screen, I don't want to press the clear button, because if I do, it'll clear something all right. It'll clear what I just put in, which is not what I want to do. I'll put my 2x plus 1 back in. To get off of this screen, we will push the second button and the mode button, which has quit in blue up above it. Second, mode, takes me back to my home screen. Before we actually draw the picture, I want to mention the zoom button, which is the third button on the top row. It's this one. There's a wide variety of choices here. We'll talk about some of them in just a bit, but for right now, I want to observe that there is a Z standard. That's choice number 6 on this menu. The standard window, Z standard, plots x's that are between -10 and +10, and y numbers that are between -10 and +10 as well. We can adjust that manually, or we can use one of the built-in zoom factors, but for right now, we'll stick to the standard window. I may be able to get out of this one by clear. Let's see. Yes, I can. So we have y1 equals 2x plus 1. I'm going to push the zoom button and make choice number 6. The x's that it's plotting are -10 all the way up to +10. The y numbers are -10 up to +10. Because the screen isn't a rectangle, the screen is a rectangle, but it's not a square, we will have to correct for that kind of thing sometimes. This is a -10 to +10 in both directions, but if you just quickly glance at it, it looks like it's longer this way than it is that way, but that's not really true. We're going to take this picture we just got, we're going to press zoom, and then on this calculator, we're going to do choice number 2. So I've got my graph in front of me here. I'm going to push zoom. Choice number 2 on this calculator is zoom in. I could either move the cursor down to that line and press enter, or most of these menus that have numbers on them, you can just type the number that you want. So I'm going to type 2 for zoom in, and then to make it actually do it, I have to type the enter key. It's the same straight line, except if you look at the little marks on the X, zero's in the middle, there's 1, there's 2, looks to be about 2 1/3. When I zoom in, my X's only go from negative 2 1/3 to positive 2 1/3, and likewise for the Y. If I want to look at a little piece of a graph, the zoom thing is very convenient for me. Also, if I go to the zoom windows, if I do choice number 3 and then enter to make it happen, that zooms me back out again. So I'm now back to the standard viewing window. If I say zoom and choice number 3 and enter again, I'm zoomed even further out. You can move around on a graph using the trace button. So I think I'll mention that just briefly. There's the trace button. It's the next to last one on the upper row. Push trace and then say the right arrow key. This moves me along the graph that I'm on. So you can see that the X coordinate's about 14 now. The Y coordinate's about 30 some odd. This is very convenient if I want to move around on a graph. To move backwards, I'll press the left arrow key. I can hold it down to keep it repeating. To go back to the standard viewing window, zoom, choice number 6. Now, there is one thing that people will sometimes trip over. A lot of the modern calculators would like to emulate the kind of notation that you see, say, in Mathematica. So what I'd like to do is, that example I kept using the other day, y equals x cubed minus 5x squared plus 5. If you're in the math print mode, this is the sequence of keystrokes you have to use. If you're in the classic mode, this is what you would have to do. And I want to illustrate this by actually drawing the pictures both ways. So I'm going to go into my y equals menu. This time I really do want to get rid of that 2x plus 1, so I'll press clear. In the mode setting, you have a choice up here at the top between Math Print and Classic. If you've got an older calculator, you may not have the choice. It may be Classic by default, but on the new ones, you do have a choice. Right now, Math Print is highlighted. So I'm going to go into my y equals menu. I'm going to say x raised to the 3rd power. If I keep on typing, the stuff that I'm going to type is going to be going along with the 3rd power bit. For instance, like that, which is not what I want. I move backwards with my cursor, and I'll use the delete key to get rid of this stuff. I've put in the x raised to the third power. To get down off of the exponent, press right arrow, and then minus 5x raised to the 2 power. You've got that same situation, so press right arrow again, plus 5. If you're in the math print mode, to get out of the exponent business, just press right arrow, and that'll do it for you. We'll draw this graph using the standard viewing window. And of course, this is the same picture we were getting the other day, but in detail. What if you were in classic mode? So I'm going to go into my Y equal menu, press clear to get rid of all this stuff. In the mode setting, I'm going to put the cursor on classic and press enter. So now we're in classic mode. I want to put in the same function. Y is x cubed, but notice it didn't put the exponential picture that you had before in, so I can just type minus 5x to the 2 plus 5. In classic mode, that's how we would put this in. And then zoom 6. Of course, it's going to be the same picture because it's the same formula. The only difference really between what you have to type is, in the one that's more modern looking, the math print one, you actually have to type a little bit more to get down off of the exponent than you would if you had done the classic mode. It doesn't matter which one you do, they mean the same. Now our picture here, I can see the high spot on the graph. I can see the graph cutting across the x-axis here and there. It looks like there's a low spot here, but I can't quite see it because my y numbers don't go down low enough. So if I want to adjust that manually, I can do that. Press the window button. Right now, we're on the standard viewing window. X min, the smallest x, is -10. X max is +10. The smallest y number is -10. The biggest y number is +10. I'm good with all of those numbers except for the smallest y number. I want it to be more negative than it is. I want it to be smaller. So I'm just guessing. I'm going to make it -15. And we need to know something. I can't use that minus sign. For some bizarre reason, you'll get an error. If I want to put in a number that's -15, I have to use that one instead. So I'm on the correct line. Y min equals negative sign 15. I don't want to do zoom 6 because that would put me back -10 to +10 again. If I want to draw the graph using these numbers that I just put in, I just press the graph button. And you can see that there's more negative y than there used to. And now I can see the low spot on the graph as well. So sometimes you'll have to adjust the window a little bit by hand like this so that you can see the parts that are interesting to you. So this is how we found that low spot, how we displayed it on our picture. We say that at the high spot, the function has a relative maximum, a local maximum. The function there is as big as it ever gets, at least nearby. This spot, close to that spot, there's no place where you have a smaller function value. So we call that a local minimum. The place that it happens is at a minimum point. Not only that, there are 3 places where the function is equal to 0. 3 places where x cubed minus 5x squared plus 5 is 0. The next thing I'd like to do is I'd like to figure out how to use the calculator to locate all of these places. Firstly, we're going to find the high and the low spot. So I'm going to say second. If you look at the trace button in blue up above it, it says calc. So I said second, and I'm going to press the trace button, and this gives me various calculations that I can do. I want to find a maximum. This is choice number 4 on my screen here. So press 4, and it's going to ask you for some stuff. It wants you to give it a number that is to the left of your high point. Then it's going to ask you for a number that's to the right of it. Then it's going to ask for an estimate of where the high point is at. You move around on the graph with the cursor keys, just like you did in the trace thing. So if I want to be a little bit to the left of the high spot, I pressed the left arrow key a few times. Then you press enter. Now it's asking me for a right bound. It wants a number that's a little bit to the right of the high spot. So I'll do the right arrow key a few times so that I'm now to the right and press enter. It needs an estimate for where the high spot is at. So I'm already sitting pretty close to the high spot. I'll use that number as my guess. I'll just press enter. And very shortly, it comes back and tells me that x is 8.206 e negative 7 and y is 5. If you know scientific notation, that number is 8.2 some odd times 10 to the negative 7, which in reality is an extremely small number. Oh, I used a different calculator on this before, so pardon me. 0.000000082 some odd. It's practically equal to 0. Calculators are imperfect. You have to expect little rounding errors like that. But up to the rounding error, we have located the high spot. I also want to locate this spot. We'll do it exactly the same way. Second, calc. This time I want the minimum. I want choice number 3 on this calculator. It needs a number that's to the left of where the low spot happens. Actually, I'm already sitting at the low spot, close to, a number to the left of the low spot, but I'll make it easier for the calculator by getting a little bit closer. Then it wants a right bound. And since I'm reasonably close to the low spot where I'm sitting, I'll use that as my guess and press enter. And very quickly it comes back and tells me that x is 3.333 and then some digits down at the end. If we knew calculus, we would know that the exact x is 3 point and then an infinite number of threes. But again, we get a little rounding error. But at least up to that degree of accuracy, we now know where the high spot and the low spot are located at. The next kind of calculation that I want to look at is on the same x cubed minus 5x squared plus 5 function. Where does that function take on value 0? If I look at its graph, I would want the y-coordinate to be 0. And there's going to be a place there, a place there, and a place there. I want to figure out on my calculator how to solve such things. Back into our menu again. Second, calc. We are looking for what they call a 0 of the function, a place where the function takes on value 0. On this calculator, I want choice number 2. Now, I'm going to get my zeros in the same order that I got them before, so I'm going to back up until I'm to the left of this first one. There's my left bound. I'm now a little bit to the right of this first 0, and since I'm fairly close, I'll use that number as my guess. And very shortly it comes back and says x is negative 0.91 some odd. So this is the first root. Luckily, electronics are fairly robust. I want to find the location of that one now. Second, calc. I'm looking for a 0 of a function. I always like to get reasonably close to what I'm looking for. So the x number here is a little bit to the left of the x number that I'm after. Enter. Then I need to give it a right bound. I need to move the little cursor until it's a little bit to the right of what I'm looking for. That should work fine. Enter. And then it needs a guess. My right bound looks to be a pretty good estimate for the solution that I'm looking for, this second one. So I'll just press enter again, and shortly it comes back and tells me that x is 1.1378 some odd, which is my second solution. The last one is got the same way. Second, calc, looking for a 0 of a function. And as I said before, I'm already sitting to the left of the third solution, but I like getting closer. So I'll put my cursor there and say enter. I'll move it a little bit to the right, enter, and I'll use that as my guess. The third solution is x equals 4.78128838 to the degree of accuracy the calculator is able to give me. So not only have we found the high and the low spot, we've also found the 3 places where x cubed minus 5x squared plus 5 takes on the value 0. If someone asked you, solve the equation 3x squared plus 5x plus 1 equals 2x plus 4, there are several ways you can do this. One of them is to subtract one of these quantities from the other and say the result has to be 0. So 3x squared plus 5x plus 1 as a number minus the number 2x plus 4 needs to be 0. If I draw the graph of y1 equals 3x squared plus 5x plus 1 minus 2x plus 4, the places where y is 0 are going to be the places where these two quantities are equal to each other. So this would give me a way to solve equations. We will go back in and get rid of our old thing with clear. Now, strictly speaking, I don't have to put the first thing in parentheses, but I'm going to anyway. 3x squared plus 5x plus 1, that's one of the two numbers, minus the other number is 2x plus 4. We could algebraically simplify that, but I'm being lazy. I'm going to graph this, and as a first guess, I'll put it on the standard viewing window. The places where that cuts across the x-axis is the x's where the y1 is going to be 0, but y1 is the difference between these two things. If y1 is 0, these two things are equal to each other. So I'll do my usual business here, looking for the 0 of a function. One of the zeros is about negative 1.618 some odd. And the other one is 0.618034 some odd. You'll notice that I didn't do any talking there because we've now done this 5 times, 3 for those roots of the other one, 2 here, so we ought to be getting the hang of it now. There's another way you can think about this. If you want to solve an equation that looks like something that involves x equals something else that involves x, if you drew the two graphs separately instead of subtracting them, so this one is the graph of y equals f of x, and this one is the graph of y equals g of x. If you're sitting here in case A, the g of x is up above the f of x, so they're not equal to each other. If you're in case B, g of x is bigger than f of x, y coordinates now, so you don't get a solution at point B, but at point C, the y coordinate that you get out of f of x and the y coordinate you get out of g of x are the same. At point C, f of x and g of x are going to be the same number. If I had a way of finding intersections of graphs, I could locate point C. Its x coordinate will be a solution to my equation. And of course, there is another solution. It's whatever x coordinate goes with that spot. So we're going to have a new idea. To solve g of x equals f of x, draw the graph of f, also draw the graph of g, find out the x values where they intersect, and you're done. As an example of this, I want to solve the equation x plus 2 equals x squared minus 4 using this idea that we just talked about. So I'm going to go into my y equals menu. I get rid of the old stuff with clear. one of my graphs is going to be y equal x plus 2. The other is going to be y equal x squared minus 4. I'm not subtracting them this time. I'm just drawing the graphs separately. So I'll try the standard viewing window. There's y equal x plus 2. There's y equal x squared minus 4. And as you can see, they intersect in two different places. I want to demonstrate how you use the built-in calculator routine in order to find the points of intersection. So I've got my picture in front of me here. I'm going to say second calc, except this time it's not 0 that I'm going to use, it's intersect, which is choice number 5 here. So I'm going to type 5. It needs to know what I'm going to call the first curve, which is the blue one here. I'm already on the first curve, so I'll press enter. It's going to call the second curve the red one, the parabola, enter. It needs a guess for the intersection point. Where I'm sitting at is a pretty good distance away from the intersection point, so this may or may not work out the way I think it's going to. It gave me the left one. It says that x is negative 2. Allegedly, that's one of the two solutions of my equation. To get the other one, this time I really do have to be a little bit careful about how I'm positioning things. So I'm going to say second calc. I'll do intersect again. Before I tell it first curve and second curve, I'm going to move over more closely to the other intersection point because I don't want to lock back in on the first one. I already know where it's at. The first curve now is the blue curve, red one, and I'll use where I'm sitting at as my guess. And it comes back and tells me that x is 3. Allegedly, my solutions are x equals negative 2 and x equals 3. A careful person will check this. I'm going to see if x equals negative 2 works in my equation. If x was negative 2, x plus 2 would be 0. If x was negative 2, x squared minus 4 would be 4 minus 4, which would be 0, and I get the same number. So for x equal negative 2, x plus 2 and x squared minus 4 are equal to each other. How about x equal 3? If x was 3, then x plus 2 would be 5. If x was 3, x squared minus 4 would be 9 minus 4, which is 5, and these two numbers are equal to each other. So like before, when x is 3, x plus 2 and x squared minus 4 are the same number, and x equal 3 is a solution of my equation. Lastly, for now, I want to solve an inequality. I want to solve f of x is bigger than or equal to g of x. If f of x is bigger than or equal to g of x, then g of x isn't bigger than f of x, and f of x minus g of x can't be negative. So here's an idea. I'll draw the graph of y equals f of x minus g of x, and I'm going to find out all the places where the y coordinates 0 or bigger. These are going to be the places on or above the x-axis. In terms of pictures, to solve this, I'm going to draw the graph of y equal f of x minus g of x, Suppose it looks like this picture. Over here, the y is negative. F of x minus g of x is negative. F of x is less than g of x, so you don't want that part. Between negative 3 and 1, the y is bigger than 0. F of x minus g of x is bigger than 0. F of x is bigger than g of x, so the numbers from negative 3 to 1 are solutions of your inequality. Between 1 and 5, the y is negative again, so that's not going to work for me. And once you get past x equal 5, y is positive, all such x's bigger than 5 will be solutions of my inequality. So this would say x is between negative 3 and 1. Also, x is 5 or bigger. These are the solutions of your inequality. At the moment, we won't have a lot of use for this, but at some point in the future, we will. This has been a very short, hopefully concise introduction to how you use your calculator to solve equations, find points of intersections, solve inequalities, and all of that sort of stuff. I hope that this is clear enough so that everyone can easily follow. We'll talk again soon.